Hi everyone, my name is Nick Oborny and I'm an applications engineer in the Analog Motor Drivers group at Texas Instruments. Today I'm going to give a brief introduction into Texas Instruments Smart Motor Gate Drive technology. Smart Motor Gate Drive is the integration of many common system components in the motor drive system into the Motor Gate Drive Integrated Circuit, or IC. This integration allows for the gate driver to provide more control of the external MOSFETs, take steps to protect the external MOSFETs, and allow for the optimal trade-offs between efficiency and robustness. In DRV8X motor gate drivers, this technology is often referred to as iDrive and T-Drive. The next few slides will explain what exactly these terms refer to. The first component of the technology is labeled as T-Drive. At a high level, T-Drive is a state machine internal to the gate driver that provides for both protection and optimal driving of the external power MOSFETs. To boil it down, this is done through three different building blocks of the T-Drive state machine. Building block number 1 works to provide the optimal dead time between the high side and low side power MOSFETs during switching. Dead time is a technique to prevent a period of time in which both power MOSFETs are on. If this were to occur, a virtual short circuit would be created between the supply and ground, leading to excessive heating and potential damage of the power MOSFETs. This event is commonly referred to as shoot-through. The T-Drive state machine works to prevent this by monitoring the gate voltages of the high side and low side MOSFET. By ensuring one MOSFET is off before the other is enabled, the gate driver can insert the optimal amount of dead time that prevents shoot-through but minimizes efficiency losses. Building block number 2 focuses on preventing another failure mode in switching power systems referred to as DV/DT, parasitic turn-on. DV/DT turn-on is a scenario where the switching voltage can couple into the low side MOSFET gate, potentially causing shoot-through. The T-Drive state machine works against this mechanism by providing a strong discharge path on the low side MOSFET gate while the high side MOSFET is switching. This removes parasitic charge in the MOSFET and reduces the overall induced voltage on the gate. Building block number 3 provides additional protection to the system by monitoring for short circuits on the MOSFET gate. The T-Drive state machine monitors for gate shorts by checking the gate voltage after the switching event has completed. If the gate voltage is stuck high or stuck low, this indicates an issue with the MOSFET gate, and the gate driver will take an action according to its configuration. These actions may include shutting down the gate driver and/or reporting a fault to the external controller. The second component of the technology is labeled as iDrive. At a high level, iDrive is a gate drive architecture that allows for the gate driver to adjust the output current that is delivered to the power MOSFETs. This architecture provides several benefits since the gate current directly corresponds to the switching speed of the power MOSFET. First, by providing an adjustable drive current, the system designer can easily scale the gate driver to match different external MOSFETs and system requirements. This allows a single gate driver to be easily used in different configurations and applications. Second, with an internal method to vary the drive current, the system can remove the external components that are typically used for this. These components usually include several resistors and a diode for each of the power MOSFETs. This reduces BOM and assembly costs in addition to reducing the overall solution footprint. Lastly, since the drive current can be adjusted through a simple register write to the gate driver, this allows for system designers to quickly evaluate trade-offs between switching speed and parasitic MOSFET effects. The waveform to the right shows the MOSFET slew rate across multiple drive current settings of a DRV8X motor gate driver. For more information, you can refer to the application report SLVA 714 titled Understanding iDrive and T-Drive in TI Motor Gate Drivers. You can find a link in the video. This application report gives an in-depth look at this technology and the system benefits it provides. In addition to the application report, an upcoming video series will go in-depth on the key application concerns in motor gate drive systems and how TI's smart motor gate drive technology can address these. Be on the lookout at training.ti.com. This technology is available today on DRV8X motor gate drivers for multiple motor types, including brush DC, stepper, and brushless DC motors. In addition to this technology, these gate drivers provide additional integration and benefits specifically related to the motor type they support. Additional features include current regulation, onboard power supplies, motor control schemes, and many more. For more device information, follow the links to the corresponding product page. That is it for now. Thanks for watching.